Hey guys, in this video we're going to take another look at direct proportion. So we're going to go into more detail, some different types of questions. If you haven't checked out the introduction video on direct and inverse proportion, do go back and check that out, because I do mention some stuff there in more detail than I'm going to here. Okay, let's get cracking. So first of all, a tiny bit of revision. Remember that when two variables are in direct proportion, we write their proportion as y alpha x. This little alpha sign that looks like a squiggle or a fish is just used to denote a proportion. So we read that as y is directly proportional to x. And the equation that links our two variables together is y is equal to k times x, where k is what's called the constant of proportionality, which sounds a lot scarier than it is. It just tells us how y and x are related. So y might be equal to 2 times x, it might be equal to 10 times x, etc. So also remember that when we're playing with direct proportion, our two variables change in the same way. So if the value of x doubles, the value of y will double. If the value of x reduces by a third, the value of y will reduce by a third. Most importantly though, as one variable gets bigger, the other variable gets bigger. So they alter in the same way. Okay, let's get cracking. So to kick us off, we've just got a purely algebraic example here before we attack the word problems. So we've got y is directly proportional to x. That's cool. So we start off with how they're related. Then we're told when x is 7, y is 21. So those two pieces of information there are what we call the initial conditions. So when x is 7, y is 21. Those are our initial conditions. Those are what we can use to work out the exact relationship between the variables. So we want to find the value of x when y is equal to 90. So how do we do that? Well, first of all then, let's write down the proportion. So we know y is directly proportional to x. Now that means then that y is equal to some number k times x. Now this is where our initial conditions come in. We know that when x is equal to 7, y is equal to 21. So we substitute those values in. So we would get 21 is equal to k times 7. So 7k. And then we've now got an equation that's fully in terms of k. If we just divide by 7 now, we will find that k is equal to 21 divided by 7, which is 3. So now we know the value of k, we now know the exact relationship between y and x. We now know that y is equal to 3x. So whatever x is, y is 3 times bigger than. So now our mission is to find the value of x when y is equal to 90. So let's go over here. So we now substitute y equals 90 into y equals 3x. So that would give us 90 is equal to 3x. So then to get x on its own, we divide by the 3, and we would get then that 30 is equal to x, or x is equal to 30. So that's how we do. That's the basic setup to these questions. We do very often get given word problems. That's what we're going to take a look at now, a few of those. Okay, example 2. So the cost, £C, is directly proportional to the number of pizzas ordered, P. When P equals 8, C is equal to £28. Now we want to find the formula linking C and D. So this is a very real life one, quite an easy one to picture. The more pizzas you buy, the more money it's going to cost you. So our first mission here then is to turn this sentence, the cost £C is directly proportional to the number of pizzas ordered, P. Our first job is to turn that sentence into maths. So what we can get out of that is that C is directly proportional to P, the number of pizzas ordered. As an equation, we can write cost is equal to K times the number of pizzas. Okay, so that is that long sentence turned into a really nice short equation. Okay, now we use the initial conditions. So when P equals 8, the cost is £28. So in other words, when we order 8 pizzas, it's going to cost us £28. So if we substitute that in, we get £28 is equal to K times 8, or 8K. So here, K is the cost of a single pizza. If we order 8 pizzas and they all cost the same amount of money, then the total cost is going to be 8 times the price of a single pizza, as we have here on the right hand side. So then to find the value of K, divide both sides by 8. Now 28 divided by 8 is 3.5. In terms of money then, that's £3.50. So K here is equal to £3.50. But when we write the equation linking the two, remember C is the total cost in pounds, so we don't really need to write the pound sign twice. We can just write C pound equals 3.5 times the number of pizzas. So C equals 3.5p. So we have the exact relationship linking C and P together. So now we can do part B. Find C when P equals 2. So what we're finding is the cost then of 2 pizzas. So we just substitute in P equals 2. So the cost C pound is going to be 3.5 times 2. So that tells us the cost is going to be £7. So C is equal to 7. Cracking. Okay, example 3. So here we're given our initial conditions in a table. Now this can happen. So part A, deduce whether x and y are directly or inversely proportional. Not sure where proportional has gone, it's fallen off the screen. So we need to deduce whether x and y are directly or inversely proportional. So what have we got? Well, we're told that when x is equal to 2, y is equal to 5. And then we're told that when x is equal to 5, y is equal to 12.5. So what's gone on there? Well, x has increased from 2 to 5, and y has increased from 5 to 12.5. So the fact that they have both increased tells us then that they are directly proportional. Not surprising given that we're in a directly proportional video. Okay, so now we need to find the value of A. So what we know is that when x is equal to A, y is equal to 50. So what we need to do here is the same game that we played in the last few examples. We need to find our exact relationship between x and y. So we've deduced that they're directly proportional, so we could say that y is directly proportional to x. Then in terms of their equation, y is equal to k times x, like that. Now we have a choice of initial conditions here. We either know that when x is equal to 2, y is equal to 5, or when y is equal to 5, when x is equal to 5, y is equal to 12.5. Now I would always go for the smaller numbers. Generally, smaller numbers are easier to deal with. So, when x is 2, y is 5. So if we substitute that into y equals kx, we get 5 is equal to 2k. And then if we divide both sides by 2 there, we get 2.5 is equal to k, or k is equal to 2.5. So up to there then, we now know our equation linking x and y together. We know y is 2.5, whatever x is. So y is equal to 2.5x. Okay, so now we can find the value of a by using our equation. So, substituting the values, we know that y is equal to 50 when x is equal to a, so 50 equals 2.5a. And then as our last step, we just want to divide both sides here by 2.5. Now 50 divided by 2.5 gives us 20. So we would get 20 is equal to a. So that's our value of a. Let's test it. If a is equal to 20, then we know that y is 2.5 times 20. 2 times 20 is 40. 0.5 times 20 is 10. 40 add 10 gives us the 50 as we want it to. Cracking. Okay, example 4. Again, another very real life example. A car can travel 240 kilometers on 20 litres of petrol. So here we're not told anything about the proportion. We have to use a bit of common sense. Now we know from real life that if you travel greater and greater distances, you need to put more fuel in your car. So it is indeed an example of direct proportion. So let's see. So how much fuel would it use to travel 180 kilometers? Okay, so hopefully by now you're quite happy that we need to find the exact equation linking the two before we can attack that. So, first thing we can write down is that the distance is directly proportional to the amount of petrol. So, the equation linking them is D equals K times P. Okay, now we use our initial conditions. So here we know that D is 240 when P is 20. So we would get 240 is equal to 20 times K. And then finally, to get K on its own, divide by the 20. Now 240 divided by 20 is exactly the same as 24 divided by 2. Which would give us K is equal to 12. Okay, so now we know the exact relationship between our two variables. We know that D is equal to 12 times P. So distance is equal to 12 times the amount of petrol in litres. So how much would it use to travel 180 kilometers? Well, we substitute in D equals 180. So we get 180 is equal to 12p. And then we divide both sides there by 12. Now 180 divided by 12 would give us 15 for the value of P. So we would need 15 litres to travel 180 kilometers. Cool. How far could it go on 30 litres? Okay, so this time we know how many litres we've got. We want to work out how far we can go. So remember, we worked out that the distance is equal to 12 times the amount of petrol. So if we've got 30 litres, we are going to get D equals 12 times 30, which is equal to 360 kilometers. So on 30 litres of petrol, we can go 30 kilometers. Cool. Okay, on with the next. So proportion questions aren't always just about y and x. We might use other letters, we've seen that. We might also use powers. So here we've got y is directly proportional to x squared. When x is 5, y is 50. Find x when y equals 128. Okay, so even though we've got x squared instead of x, we just play exactly the same game. So let's first of all write down the proportion. So we know y is directly proportional to x squared. Cool. So the equation that we would use is y equals k times x squared. So we've got our equation, or our general equation. Now we need to find the exact equation. So we use the initial conditions. So we know that when x is 5, y is 50. So if we substitute that in, we get 50 is equal to k times 5 squared. Now 5 squared is 25. So we get 50 is equal to 25k. Now if we divide both sides there by 25, that will tell us k is equal to 2. And then the exact formula between our two variables is y equals 2x squared. So that's our formula linking y and x together. Now we want to find x when y equals 128. So we just substitute in then y equals 128, and that's equal to 2x squared. Divide by 2, we get 64 equals x squared, and then if we square root, we get 8 is equal to x. So x is equal to 8. Jobs are good. Now we also get another answer there, don't we? Because when we square root, we always get 2 answers. So we could also have minus 8 is equal to x. Or we could just write x equals plus or minus 8. Alright, jobs are good. On with the next. Okay, so y is directly proportional to the cube root of x. When x equals 27, y is equal to 9. Find x when y equals 15. Okay, so again, even though we're now dealing with a cube root, it's exactly the same game. So we know that y is directly proportional to the cube root of x. So let's write that down first. So y is directly proportional to the cube root of x. Cracking. Now the equation that we would use then is y equals k times the cube root of x. Okay, so now we need to find the exact formula linking the two. So when x equals 27, y equals 9. Substitute those values in, we would get 9 equals... Now the cube root of 27 is 3. Because 3 times 3 times 3 equals 27. So when x equals 27, we get on the right hand side 3k. Okay, and then divide by 3, we get then 3 is equal to k. K is equal to 3. So then our exact formula linking the two together is y equals 3 times the cube root of x. So now we know exactly how they're linked together. We can do the final bit of the question. Find x when y equals 15. So we substitute in y equals 15. So we get 15 is equal to 3 times the cube root of x. Now if we divide both sides by 3, we get 5 equals cube root of x. And then we cube both sides. To undo a cube root, you cube it. Now 5 cubed is 125. So we get 125 is equal to x. X is equal to 125. Cool. Right, one more. And it's a very, very wordy question. So, don't get scared by all the words. Let's just read through and see what we can pick out. So, a new dishwasher costs £159. Delivery charge, £C, is directly proportional to the distance, d kilometres. A delivery to a distance of 12 kilometres costs £9. Work out the total cost of a dishwasher delivered to 28 kilometres away. Okay, so this is quite big and chunky. What do we need to work out? Well, we know how much the dishwasher costs. It's £159. So let's highlight that. We're going to need that at the end, but we're not going to worry about it now. Now we know that delivery charge, C, is directly proportional to the distance, d kilometres. Now instead of reading that over and over again, we can turn that into a proportion. So we know that cost is directly proportional to d. So that's that big sentence turned into a nice small proportion. And then we can even write the equation there. So we know that C is equal to K times the distance. Cool. Then we know we're given initial conditions. A delivery to a distance of 12 kilometres costs £9. So those are our initial conditions. So up to there, we now have enough information to work out the exact relationship here between the cost and the distance of delivery. So let's do that. Okay, so we know then that a delivery to a distance of 12 kilometres costs £9. So that means that 9 is equal to K times the delivery distance, which is 12. So if we divide by 12 there, we get 9/12, which is 3/4, is equal to K. So now we know the exact formula connecting the cost and the delivery distance is the cost, C, is equal to 3/4 of the distance. Okay, now let's go back and read again what we're trying to work out. Work out the total cost of a dishwasher delivered 28 kilometres away. So the total cost is going to be the cost of the dishwasher itself and the cost of delivery. So we know the cost of the dishwasher was £159. So we need to then work out the cost of delivery to add on to that. So the cost of delivery is going to be 3/4 times 28. Now, whenever you're doing a fraction times an amount, as we are here, 3/4 times 28, then we are finding 3/4 of 28. Now, 1/4 of 28 is 7, 3/4 of 28 then is 21. So the cost of delivery of this dishwasher is going to be £21. Now the total cost then is going to be the cost of the dishwasher, £159, add the cost of delivery, 21, which will give us £180. Jobs are good. Okay guys, that's direct proportion. Hope it's been useful. Was this video helpful? If so, don't forget to hit the thumbs up button and leave me a comment letting me know how you get on. Also, don't forget to subscribe to the channel so you never miss any videos. For any further information, you can find me on Facebook or Twitter. Search for Maths with Melv. Cheers guys.